Thanks everyone for coming. My name's Aaron Newman. I'm the founder and CTO of a company called CloudCheckr. Here today to talk to you about kind of the threats in the cloud as we move from the data center into the cloud. How do things change? How does the hacker think about this? How do we have to change what we're thinking about to make sure that we're protecting our data, to make sure we're hack-proofing our cloud, and responding to kind of the threats in the 2016 world. The first thing to understand is just very basic. We have to change our perspective a bit. So as you move to the cloud, you have to rethink things. You have to rethink security. You have to rethink your perimeter. You have to rethink things like, as security professionals, people think a lot about network-based IDS and IPS. They think about network scanning. They think about penetration testing, vulnerability assessment. Now, I can tell you off the top, things like penetration testing don't work in the cloud because, it's basically against the terms of service, right? So you can't be doing penetration testing like that. So you have to rethink, how am I going to do these things? How am I going to get the job done of hack-proofing the cloud, of locking it down, of making sure it's secure, and yet still following the rules and still trying to do things the right way. So the other thing to understand your perspective is not necessarily to think about securing the whole cloud. Your job is not to secure cloud. Your job is to secure the workloads that run in it. So that said, you can start thinking about, rather than just securing your perimeter, it's about securing workloads, where the data's sitting. That level of security is really what you want to focus on, rather than how do I secure everything that runs in the cloud. In the data center, what did we used to do? We used to set up perimeter security, that we would go buy infrastructure. We would get a building. We would create access points to the building through a hosting provider. We'd configure firewalls and IDSs and IPSs at all those access points. So that, we put a security guard at the entrance of the data center. Those are the type of things. Then you'd have to audit your security, right? How would you do that in the data center? You'd go hire a pen testing company or a security consultant, and they would kind of grab IP addresses and start trying to poke holes. They do social engineering to try to break into the data center. They do port scanning using tools like Nmap. Various exploits on open ports, try things like that. A lot of sniffing packets. Security guys love to sniff packets and see what's going across the network and dig around for backdoors like, wireless access points or VPN access from other places. So those are the things that you used to do. Now, a lot of that just doesn't make sense in the new cloud world. Things are just fundamentally different. First of all, the idea that physical security really isn't your main concern anymore. That's really part of what Amazon gives you, is that physical security. The idea used to be you don't want somebody to break into your data center, steal a server, steal a hard drive. Well, what's the equivalent of that in the AWS world, where the idea is using the Amazon API, you could do something like create a snapshot or download an EBS volume. And that's very much the same as stealing a hard drive. So really what you need to think about is the idea of physical security really morphs into the idea of virtualized APIs, where people, what they used to be able to do physically steal stuff, they can virtually steal now through this. So really, you have to think about the availability zones are now protected by AWS. You have to think, and the physical assets are secured there, but now you have to think about the virtual security. The idea of IAM. IAM really becomes your new virtual security. This is the traditional Amazon slide showing your shared responsibility model. So Amazon provides you the foundation. They provide the services. They're securing the data centers. They're securing your availability zones. They're giving you the encryption capabilities. They give you every form of encryption you could possibly need, key management servers, HSMs, all of that. Amazon takes care of the security of the cloud. Now, that doesn't mean you're secure. What really you have to also make sure you're defining the controls around that security properly. And that definition is oftentimes a trade-off between functionality and risk. So you have to balance that. A perfectly secure app is one that's totally locked down, but it's useless. So you have to make it open enough where it's useful to whoever the end consumer is, yet secure enough. So there is a trade-off there. So that's where your responsibility is to define how you're going to use the capabilities and controls that Amazon gives you. AWS is giving you those capabilities to do anything you want securely. Some of the principles don't change, right? The idea of you want to minimize your attack vectors. So how do you lock, again, if you wanted perfect security, you just lock everybody out of the app, but you can't do that. So what does a firewall, for instance, what does a firewall do? Does a firewall prevent attacks? No, what it really does is reduces your surface area. You set up a firewall and you only allow port 443 through it, right? What have you actually done? You've reduced the surface area to only the single port that you have very robust security on. So the idea, a lot of these principles don't change. In the cloud, we want to reduce our surface area. So we want to use the mechanisms out of AWS that allow us to firewall things and reduce what's exposed to the public internet, reduce what's out there. So that kind of principle doesn't change. Principles like defense in depth. You never want to just rely on one layer of defense. Think about your network and your application, your workloads, having multiple layers of defense. Assume a hacker is going to get past one layer. So you have multiple layers, so even if they get past one, they got a second layer. Even if they get past that, you got a third layer. And then it becomes a trade-off of how many layers do I want or are reasonable versus how much protection do I need. So you want to think about that defense in depth, and you have those capabilities. We're going to cover those capabilities. You have a lot of layers of defense within AWS. So some attack vectors don't change at all. You're still going to have to worry about application level attacks, things like user privilege escalation, web application vulnerabilities like cross-site scripting or SQL injection, operating system vulnerabilities. You're still going to have to figure out how am I going to patch for shell shock, how am I going to patch for slammer or code red or whatever the latest buffer overflow or whatever security problem is out there. So you still have to worry about those vulnerabilities at the operating system, the database layer. Now, AWS makes it easier for you to actually use versions that are patched. Use versions of the operating system, versions of the database that are patched. To upgrade your MySQL database from a vulnerable version is really a configuration setting. You're not even having to go and install a patch. You're just going into the Amazon Management Console and selecting, okay, I want to be on the latest version of MySQL. So they do make it much easier. You still have to worry about that and be cognizant of the vulnerabilities as they're discovered. Some attack vectors do change. For instance, I like to talk about the idea that Amazon is a fairly homogeneous environment. So compared to a data center where you're just going to have a really broad spectrum of different hardware platforms, different software running on it, the Amazon environment is much more homogeneous. I mean, you have ELBs, you have a discrete set of EC2 types that you can use. You just have a much smaller variety of operating systems and network devices and databases and all that are running there. So what does that mean? I mean, homogeneous is good in one way because it's much easier to secure, to provide a very high level of assurance around a very homogeneous environment. The negative side of that, though, the challenge of that, though, is that if somebody does find that one security issue, then it can be a very widespread problem. So for instance, if somebody today went out and found one of the more common EC2 AMIs had a security vulnerability in it, all of a sudden, a lot of different apps become vulnerable versus in a very heterogeneous environment. It's much more likely that somebody can find one avenue of attack, one vulnerable server, but then to get to a different vulnerable server, they need an entirely different attack. So it just becomes a different challenge for how to actually protect against that. So, I mean, and the biggest challenge with security is that the hacker only really needs one hole to break in versus you need to lock everything down. So you need to basically eliminate all holes. So in a homogeneous environment, it's actually easier because you have less things. You have that less of a surface area, less things you have to secure. You can focus on securing just the subset of things you're using. So the other idea is these polymorphic targets and mapping. Again, one of the threats that we face today are these things called advanced persistent threats, which are, and a lot of the attacks you hear about in the news are based on somebody breaking into a network, putting a back door in there, putting a Trojan horse in there, putting a bot in there, and then it runs for weeks or months or whatever, collecting data, collecting packets, collecting credit cards, whatever it is. So most of the attacks you hear about, everything from the Stuxnets to the Target, is all advanced persistent threats. If somebody would have detected that they would have been if they would have been exploited or would have known an attacker was in their network, a week into it, 2 weeks into it, even 3 or 4 weeks into it, the damage would have been very negligible. The problem was these attackers were in there for months at a time. And after months, there's a lot of time to map a network, understand what's running, and to penetrate deeper and deeper into the network. And that's where they end up finding these gold mines of credit card information, whatever it is. So in a cloud, this situation's very different because you have these ephemeral auto-scaling environments where if somebody breaks into and owns a single server, in a typical cloud environment, that server is spun up, it's run to do its workload, then it's spun down. What does that mean? That advanced persistent threat goes away. So the idea of, and I'm going to go in a bit more depth on this, but the idea of ephemeral resources actually helps from a security perspective, particularly against advanced persistent threats. The other thing you got to understand in the cloud is you have much less capability to do this kind of network sniffing. And the idea is you're on this shared infrastructure, so the ability to sniff packets is just not something that you have the capability to do because it would open up a lot of security issues. So there's much less of that capability. So it makes it a little bit harder to detect attacks, to see what's going on. You just don't have as much visibility into the network, which creates some additional security risk. So how do I assess my perimeter in the cloud? You know, in the old world, we kind of we'd again use these tools, Nmap, port scans, we do ping sweeps, and we'd be able to create a map of the network, the map of the perimeter. The new world is you can't do that. You can't take an Nmap scanner and start probing on Amazon to try to find the perimeter of it. Again, it's against the terms of usage, and it just wouldn't be effective because most of the IP addresses are not really in a defined network block that you own, all of that. So the cloud instead is this idea of this software-defined networks or software-defined infrastructures. You can use either of those, but the idea is you can now very easily know what your perimeter is by querying APIs, by looking at what your configurations are. So the idea is actually that it can be a much more discrete and effective way of mapping your perimeter, the fact that you're using the cloud. So the fact that you're using AWS makes it much more discrete. And in the old world, doing an Nmap was it wasn't a very scientific way because Nmap is not a perfect tool for mapping an exact perimeter. It's because it's throwing packets out there, assessing when things come back, whether it thinks something's there or not. So it's an art form, not really a science. Versus in the cloud, it's much more of a science. What's your public resources? You have a discrete list of it. The API is going to give you exactly what's public, what's not. What's the challenge of it, though? The challenge is still that you have 70 services, all with different configurations and different routing methodologies and different settings that determine whether your cloud, what's the perimeter of your cloud. So it's that you can get a distinct list, but you have to be able to then turn that distinct list of results from different Amazon APIs into something that actually looks like a map. So that is the idea. So you have really, you want to get your list of publicly accessible resources from all the different Amazon IPs, our services. You want to be able to look at security groups, routing tables, network access control lists. You want to understand your VPCs. You have S3 buckets and IAM policies. All these put together are what define a permissions model and a perimeter of your cloud. So VPCs, I mean, a lot of Amazon security is built around this idea of VPCs, and they're software defined. Another term that's becoming very frequently used is kind of micro-segmentation, where you can create these micro networks, these little small networks, even within your own cloud. So, and a VPC is a core to that. So there is a default VPC in every region. If you're really an old school, you used to be able to run resources outside of the VPCs. Today it's difficult to do that for good reasons, because it just isn't a good idea. You want that VPC so you have that security capabilities, you know. And a VPC, it is important if you want to secure yourself to really understand how a VPC works. What are all the bells and whistles, and what are all the gears to make it work, so you can make sure you're properly routing things, you're properly securing it, all of that. So, you know, the core of a VPC is you have these internet and VPN gateways. And these are, an internet gateway is basically a tunnel out from your VPC to the whole world. And a VPN gateway is to one of your VPNs within your data center, somebody else's data center. So those are how VPCs connect out. Then you have subnets within that. You have routing tables that move things within the subnets and out through those gateways. You have network access control lists, which are firewalls, stateless firewalls, security groups, which are host-based firewalls. And then you have these resources that run within them. And the resources, the main resources you see are EC2, RDS, Redshift, and Elasticache. Those are what you see inside of typically inside of a VPC. Now, if you understand this, this is a really, I think, a powerful picture that really, if you understand all of this, you probably understand 85% of the VPC and the ideas that you need. And if you look, you see there's kind of a region at the outside. So a VPC has to sit within a region. And you see kind of there's two availability zones. So a VPC can go across multiple availability zones. That's important because you need that availability. So if one AZ goes down, you still have the other AZ. Within AZs, you have subnets. That's where you actually put things. That's where you assign routers to. That's where you assign route tables to. So the route tables tell you how you get from subnet 1 to subnet 2, or how subnet 2 gets out to the customer gateway, all of that. And now you can have different route tables on different subnets. So it's really, you have a lot of control over how things route, how things are talked to each other, what can go in and out, all of that. But you have to understand this basic model. Once you understand that basic models, you can do a lot. So, you know, again, we talked about defense in depth at the beginning. And VPCs have, even at just the network layer, they have two different types of defense layers. They have network access control lists, NACLs. So, and they have security groups. So by far, the vast majority of people use security groups today and don't use network access control lists. So a network access control list is really, it's a virtual firewall that you assign to the VPC and more specifically to the subnet. So you assign NACLs to a subnet. They're stateless, meaning if a packet comes in, packets usually, if a packet comes in on port 443, the response to that packet goes out on a random port above 500. And it depends on your operating system which port it goes out on. But you have to understand that about TCP. When something comes in on one port, it goes out on another high port. So the idea that it's stateless, meaning that if you're going to allow if you're going to allow connections in on 443, then you have to allow connections out on everything above port 500. And by 500, I'm being very broad. If you look at the Amazon documentation, they give you exactly what the ports are depending on your OSs and what devices you're using. But, you know, so stateless means you have to handle rules that handle not just the inbound, but the responses to inbound connections as well. And the same way going out, right? So if you're trying to connect out on port, you know, 22, then to allow responses back in, you have to allow all responses above port 512 or something like that back in. So it makes it a little bit more difficult to properly secure it, because if you want things to go in and out, you really have to open up everything above. All of those high ports really have to be exposed or open. Rules are kind of evaluated numerically. So, you know, it goes to the first rule, you know, 100, then 101, 102. And if a packet comes through and it meets any of those rules, the first one it meets, that's the one it gets. So if you have if port 101 is to allow port 80, and then rule 102 is to deny port 80, well, you're allowing port 80 because that's the first rule that it meets. So understand that. So denies can be overridden by allows, which is a bit of a different, that's not usually how network access control or access control list works. So you have to watch for kind of ineffective rules like that. Security groups, these are the other side, which is host-based firewalls assigned to an instance. So when you spin up an instance, you tell it one or more security groups that it's assigned to, and then those are stateful. So if I define I allow incoming packets on port 80, I don't have to worry about the response packets. The security groups will be smart enough to know that's a response to that packet, that incoming packet, and so you don't have to worry about that. So it's much easier to manage that way. The rules are cumulative. So if I have a deny on port 80, it doesn't matter where I put an allow. That deny is going to deny it. So now what's the complication behind this is that NACLs I can set on a VPC, and I know anyone who spins up anything in that VPC is gonna have to follow those rules. When I use security groups, if one new guy doesn't understand the security problem, he spins up an instance in there, doesn't assign the proper security group, then you leave a huge hole that becomes a target in your VPC. And so if you use security groups as your main thing, you have to be very, very diligent about making sure you don't end up with one resource in there that's assigned the security group, the wrong security group. And so this is where defense in depth starts to come in, is if I can use some VPC, NACLs, and security groups, then even if I make a mistake on one of those levels, the other one can still protect me. So that's what I mean by defense in depth. No security is ever perfect. As you see, there's trade-offs for each of these. And it's really your job to make sure you're implementing the controls properly and making sure you're not opening that one hole up that the hacker needs. Because again, somebody spins up a box in your production VPC, it doesn't have anything valuable on it, but it's open to the world. If some script kiddie out there stumbles upon it, he can get a packet into it. Now from that, he installs a bot, and he can start touching your other boxes, right? Because now he's behind the firewall, and there's probably some trust there. So you got to understand how Amazon uses IPs with EC2 as well. So because there's a lot of different, they give you as much flexibility as you can possibly imagine with how to assign IP addresses. So out of the box, you get an instance. Every EC2 has an instance ID that's like an I and 8 hexadecimal numbers. And then a friendly name as well that's kind of a tag. So people can get to your EC2 instance through, for instance, the Amazon API, the AWS API, through that instance ID. So that's one way you can see people get there. Now, as well, every time you spin up an EC2 instance, it's given one or more private IP addresses. So again, private IP addresses cannot be routed to the internet, so the only people that can get to that are other instances in the same subnet. Or even in the same VPC, depending on how your routing tables and all that works. But certainly can't get to it from the internet. So if you start up an instance and you only give it a private IP, then nobody from the internet can get to it. Of course, if somebody can get to another instance in that subnet or VPC, they can use that to then route to you. So you have to be careful of that and understand it. So it's really, you have to understand this idea. You also, if you check the right box when you spin up an EC2 instance, you get assigned a public IP address. And that public IP address is not something you pick. It's just one of the free IP addresses Amazon hands off to you when you spin it up. And that's likely reused. Somebody else was likely using it for some other purpose 20 minutes ago. So understand what that means. So when you spin that up, you're going to get this IP address that it's a public IP address that can be routed to and from the internet. So be cognizant of that. And then you can also assign elastic IPs. So that's where you pick an IP. Well, you don't pick an IP. You ask Amazon for an IP. You're given it, and then you can hold that forever, or as long as you keep it registered. So, but realize, just because elastic IPs are not the only way that traffic can get routed to your EC2 instances. They also have public IP addresses as well. If they're sitting in there, even if they only have a private IP address, if there's another server in that VPC that also does have a public IP address, that can become a jump point. So understand all the intricacies of how people can get to a server. Don't just assume because it doesn't have a public IP address that there's no way that somebody from the outside world can get to it. So how do you run your vulnerability assessments? Most of us have, and nearly anyone who has any level of sophistication in infrastructure has some kind of vulnerability assessment program running, and whether your best practices are, I need to run an annual, or quarterly, monthly, or even weekly kind of vulnerability assessment test. You have lots of tools to go check and see, is this thing properly patched? Is it look like it's secure? So this is very difficult in the cloud because the idea is, again, things are ephemeral, they're elastic. I have workloads that are scaled up, scaled down, and so most VA tools are designed to say, I found an IP address, I know that's a server, I'm going to scan it, right? What good does that do you in the new world when that server is going to be gone in 20 minutes and a new one's going to replace it? Whatever I just scanned, that was kind of, it didn't accomplish much. So you have to rethink this strategy of how am I going to keep vulnerability assessment. I'm still going to need to run vulnerability assessments, but I'm going to have to do it in a way that effectively accomplishes my end goal, but not just going out and trying to scan every server that ever is spun up in my workload. As well, there are, AWS is very diligent about making sure that you're not out there running these very, a lot of vulnerability assessments. You have to go out to a web page. You have to get approval to run those tests. You have to make sure you're not running against certain instance types. You have to be non-destructive about all the checks that you run. So there's a lot of parameters around it. So you have to be very cognizant and careful if you're going to go do this. Because if you just try to go run a vulnerability assessment from your corporate office against one of the Amazon infrastructure IP addresses, I mean, A, you're breaking the terms of service, and B, you're actually hurting other people because it's shared infrastructure. And the idea is now you're causing, whether it's, slowing down or possibly crashing other servers that may be shared with your app. So it's just not being a very good citizen, internet's or, cloud citizen either. So there's a lot of different ideas around how do I do this differently. So the idea is, do I take an AMI? This is what I see a lot of people doing is looking at AMIs, taking an AMI, spinning up an instance of that within some place that's fairly secure, running your assessments against that, verifying that it passed or didn't pass or what needs to happen. If it finds vulnerabilities, patch it, create a new AMI. And then use that AMI as a basis for what's scanned or not. So for instance, you can consider anything that's spun out of that AMI as scanned as well. That's past your vulnerability assessment as well. Now the challenge for that is what happens, how long now can you trust that, right? So if you spin it up 10 minutes if you spin up an instance from an AMI that was scanned yesterday, you can feel fairly secure 10 minutes later, it still passes all your VA tests. 3 months later, you probably can't be secure. You probably can't consider that properly scanned anymore. So now the line is, where is it? At what point does that instance drift far enough from the original AMI that you want to consider it no longer validly scanned and it needs a new scan? And so that's really where you need to consider things like, are people connecting to it and are they installing new software? If this is like, for instance, a desktop somebody can go and browse from, then you might have to be more diligent about how often you have to watch for drift from the original AMI. So these are all the things you got to factor in. It's still a very early and evolving kind of problem, so we'll see what happens in the next couple of years for how people handle these. Patching strategies. So on top of the VA, there's the idea of patching strategies. And really what we see a lot of people talking about is this no patch strategy. And that doesn't mean you don't apply patches. What that means is you stay away from patching live systems. You don't actually want to be going into a live system, logging on, applying a patch, rebooting it, whatever, right? So you want to focus on patching the AMIs, patching the templates that your workloads are actually generated off of or provisioned off of. This is really very dependent on the fact that you're doing things in a cloud, in a cloudy way. The idea is if you lift and shifted from the old world and you still have static servers that are sitting there, monolithic applications that are not spinning up and down, auto-scaling, then this strategy is much less effective. But the idea is as we move our workloads to these very cloudy perspectives where I can scale things up and down and I can reprovision them, I can systematically reprovision my workloads, then all of a sudden patching becomes much easier because I can patch the AMIs, I can patch the templates, and then just systematically redeploy my entire workload, and all the patches are applied everywhere. So, but again, it's highly dependent on the ability of you to architect your applications so that they're deployed like that. So, so look at the, Amazon does a great job. AWS does a great job of patching their OS templates. So always try to make sure you're on the latest OS templates. And as well, understand that the AMI now becomes a very valuable asset. So you really have to make sure your AMIs are high assurance repositories, that you're really protecting those. Those become the keys to the kingdom. So if somebody can get to them and install something on there, a backdoor, a Trojan, or bot, or whatever it is, then all of a sudden they become, you're actually redeploying a security problem. So you have to be very careful about making sure your repositories are locked down very well, and they're the high assurance repositories. This is also very, very effective against battling advanced persistent threats. The idea that anytime a hacker breaks in, takes over a server, well, you're doing systematic workload reprovisioning every day, every week, then you know those persistent threats are very effectively, they're just not going to stick around that long. So it really reduces a lot of the risk. So everything we talked about, what are we missing? So most people just focus on securing EC2. The problem is they're missing the 30, 50 other services that Amazon has. So if you're only using EC2, then that's all you have to focus on. But the truth is most people are using EC2 and then a couple other services for lots of other things. So you have to actually understand each of those other services. They each have unique and different access control systems, security settings, how things are logs around them. So you actually have to be fairly diligent about understanding all those. Because again, the security breach is going to happen on your weakest link. So if you are very diligent about VPC security, EC2 security, but then you leave your SQS wide open, well, the hacker doesn't have to break into there. He's going to break into your SQS and use that to tunnel into your application. So think about the weakest link, think about all of that. Make sure, you're going to have hundreds of Amazon accounts. So again, what you may see is you lock down your 10 production workloads, but in the 90 other accounts, you have a lot of dev stuff, you have a lot of QA test stuff. The hacker ends up getting into that. That can either be used to leverage their way into a production environment, or you may just have backup copies of your data there. Right? So understand that proliferation of accounts can as well increase your risk. I'm going to go through just a couple of services to show you how we've talked about VPCs, we've talked about EC2s, we've talked about how those can be perfectly locked down. RDS can be within a VPC or not. So obviously, if it's not in a VPC or VPC security is not gonna help. If it's not there, then you have to use a different set of security groups called DB security groups. And so this is just typically not a good idea to use those. You really want to use the VPCs if you can. You can actually set your database to be publicly accessible, which is, there's lots of valid use cases, and you want to be provided all the different options, but it's almost never a good idea. You really want to make sure if you're making your publicly accessible databases and putting them out on the internet, they're not nearly as robust as, for instance, I feel much better about putting an Apache server and opening up to the world, or putting a WebLogic server, because that's what they're designed for. Databases are really not designed for kind of the industrial level hacking attacks that are going to happen if you put it out on the network. They're really enterprise applications, and there's just too many zero-day exploits or unknown exploits that are out there against these databases. You don't want to put it out there. So if you do have to, for whatever business reason, put your database out there, make it publicly accessible, you have to make sure you're using security groups on it. You have to make sure that you're limiting your IP address to specific source IPs that need to talk to it. So, and that's where it mitigate, so no security option is ever entirely unsecure. It's really that if you're going to open this security, you have to mitigate it by doing something else. And so if you're going to make it publicly accessible, you have to mitigate that by using security groups that are very stringent. So, and then you have to think about things like securing your snapshots, right? So you lock your databases down, but then somebody has full access to the snapshots. Well, it's kind of like leaving Again, those are the keys of the kingdom. Somebody can take a copy of those snapshots, load them somewhere else, have access to your database. They could do things like brute force passwords, all kinds of things on a snapshot. So don't just lock your databases down, lock your snapshots down as well. So think about, how is the hacker going to try, even if he can't get into your database, can he try something else to get another copy of it? So Amazon S3, another service. You can have up to 1,000 buckets, and I see lots of accounts with billions of objects in there. So it's a massive service. It can't be within a VPC. So they actually do have support where you can create S3 buckets that have VPC endpoints, but it doesn't actually live within a VPC. So you can't sit between the client and the storage. So the idea is you need to understand, even if you've locked down your VPC, S3 sits outside there, so you still have to lock that down. So don't forget about your S3 security. It's located within a region, so it's across multiple availability zones, not housed in a VPC. Access is controlled through multiple mechanisms. So again, you have all these really robust options, but S3 does not, it's not missing a security features. They have every security feature you could imagine. Everything from encryption integrated with HSMs, KMS, SSL encryption, access logging, all of this. You have to just make sure you set the right ones is what it comes down to. So, but access can be gained through IAM policies, through bucket policies, through access control lists, through query string authentication. So our job in terms of making sure that we've set up our controls around that is, maybe we looked at all the IAM policies, we didn't realize there's a bucket policy that left this thing wide open, or we didn't realize somebody misconfigured the ACL. So our job is to be diligent and not forget that there's multiple places that a hole can be created. So never ever grant full control, right access control permissions, or right to a bucket. Grant it to everyone, or even to authenticated users, right? So you guys have seen the idea of authenticated users, and it sounds pretty secure. I mean, a user's got to be authenticated to get to this bucket. That just means they have to be authenticated to Amazon or AWS at all, right? So they can go create another account, create a user there with a stolen credit card. They're now an authenticated user. So authenticated user is essentially the same thing as everyone. So make sure you're not opening these up, because they just become, huge issues for, they're just not, there's huge security holes, right? So for instance, you may think, well, I'm just putting a copy, here I did a consulting engagement with one big organization that was like, well, I'm going to put my Trend Micro agent out on a share, open it up for the world, because I need all my internal people to be able to connect to it, download the file and install it. And what's the security problem with that, right? Well, they left it as write. They allowed everyone write permissions also to it. So somebody can go up there and replace the files with some malicious file, and now all of a sudden all your organizations are logging on, downloading this Trojan file, installing it, all of that. So these are the type of things that it's very easy to forget about, because you're like, well, it's not my sensitive data. Why would I be concerned about that? It's very easy to remember to lock down somebody's health records or credit card numbers. But it's much harder to remember, hey, if I put our employee manual out on an S3 share, and I give everyone access and I just click write also to it, I've just created a huge security hole, right? Because now somebody's going to Trojan one of those Word documents, put some kind of macro virus. I don't know what it is, but your job is not to figure out what it is that they could do. Your job is to make sure that somebody really clever can't figure out a way to use that write access to make a backdoor into your organization, into your workloads. So there's services like SQS, right? AWS SQS. It does not. Again, this doesn't live within a VPC as well. So if you're locked down your VPCs perfectly, that doesn't mean anything for your SQS security. So it's based on policy documents. So again, you may go through all of your IAM permissions and make sure they're all locked down, and you didn't realize you also should go look at the policy documents for SQS. And this policy document here is basically wide open, allows people to send and receive messages. So, receive messages is interesting because that kind of allows them to see perhaps sensitive data, but even send messages is really probably the one that's really critical because they can kind of inject. There's lots of different attacks that can happen there, whether it's a SQL injection attack or some other kind of command injection attack that can happen in some kind of send message. I don't know what it is, and even if your app is designed perfectly where it knows how to sanitize send message, it still isn't something you should do because you got to assume that somebody out there has come up with a technique you haven't thought of, is more clever than you, and has found some way to subvert the fact that they can put a command or something in one of those messages. One of your programs processes it and does something malicious with it. SNS, kind of the same idea, which is it doesn't live within a VPC. It also has policies. And so even if you lock down all the other stuff, and if you left this with everyone granted the ability to publish messages, you create another security issue, a security problem. So make sure you're locking down these and don't grant, you really need a compelling reason to be writing everyone in any of your policy documents, IAM, S3 buckets, any of that. You really need a compelling reason. Amazon has a ton of capabilities to help really reduce the risk, understand what's going on. CloudTrail was one of the services they released about 1.5 years ago, really powerful. It records every time the Amazon API is called. It supports almost all the services. Sometimes there's a lag if a new service comes out. Sometimes it might take a month or two for it to cover CloudTrail. But the important thing is that you go turn it on, right? What's the biggest problem with CloudTrail today? People don't turn it on, right? So, make sure you're going and turning it on, not just in the region that you think you're using, but in all the regions, right? So your workload may be in US East, but you should turn it on in every region. The idea is you want to see what people are trying to do, whether it's failed access attempts or spinning something up, you want to see any of that. So there's no reason just to turn CloudTrail on in US East. Go turn it on in all 10 regions, or if you're in GovCloud, make sure you have it turned on, whatever it is. But make sure you're turning on all the regions. Make sure you're monitoring it so that if an S3 bucket permission gets out of whack and now it stops writing CloudTrail events, that you know about that, right? These are all the things that are going to bite you. So CloudTrail writes into an S3 bucket near real time. Files are in JSON format. You got to find a way to ingest it and then actually know what all that means. So again, it's a big data problem. So they've provided you the ability to get all these events. Now you have to also know, what am I going to do with that, right? I'm getting 10 gigabytes of log messages a day, and that's about 700 million described tables in DynamoDB. And somewhere within those hundreds of millions of events is unauthorized access attempts and somebody trying to spin up something they're not supposed to. So your job now is to make sure you get notified of that when it happens. So Amazon CloudWatch logs, another nice little capability they added within the last year, which allows you to ship your operating system logs into CloudWatch. And that's really interesting because in the old world, you have all these logging tools that are designed to be installed as an agent on a box and then to take those log files and do something with them, right? Well, in an auto-scaling elastic environment, what do I do? My auditor is going to come to me and say, on this server, I need the audit logs for 2 months ago, right? That server was scaled down, 40 days ago, and now it's gone, because the event logs are sitting on it. So the idea is now this CloudWatch logs makes so much sense because it's shipping all this auditing logs into one place that doesn't get scaled up and down. So when an auditor comes to you, you still have the capability to produce those audit logs, even though you're in an elastic environment. So I think this is just an awesome idea, the idea of CloudWatch logs. And again, you want to monitor this now. you have everything getting shipped into one place you can manage, but you still have to figure out, how am I going to know when I see a password attack? How am I going to know when I see somebody clearing the audit logs because they did something malicious? How am I going to know when I see an unauthorized access attempt? So you still want to then figure out how to leverage these logs, not just as evidential proof when your auditor comes, but to know when something's actually going wrong. So VPC flow logs, another nice little feature that Amazon's thrown in there that's given us the ability to see what's flowing in and out of a VPC. Now, you still don't have deep packet content inspection, so you're not going to be able to actually see the packets that are going in and out. That's fine, but you at least are going to be able to see this IP address is connected to this IP address and this port connected to this IP address and this port. So you actually have the ability now to really see when people are connecting in and out. In the past, you go back 2 years ago and you just had zero visibility into what was actually flowing through your VPC flow logs coming in and out. What was your security group stopping? You had no visibility into it. This might be the most important part of the VPC flow logs, is you have the ability now to see deny connections. So when somebody's actually trying to do something, trying to get to a database within your VPC that you've blocked, at least now you have the ability to see that. So, but again, you have to actually be looking for it. So this is a big data problem where you end up with literally thousands, if not tens of thousands of log groups within CloudWatch logs. You need to be able to ingest those and then monitor that for something that's really interesting. So there's a ton of tools out there. You often see a lot of the old generic tools that were built for your data center are kind of ported over and tried to retrofit it into the cloud. So these kind of tools that are not purpose-built, they're cloud-washed, they usually fall over in the cloud, right? Because they're like, well, you got to put an agent on your box. Well, how does that work when I have workloads that are scaling up, 1,000 servers overnight, then back to 200 during the day, right? Am I installing agents on all of those? Are the agents coming up? And what's the licensing restriction? So there's a lot of problems with the tools that worked in the data center. How do they work in the new world? So you want to think about finding tools that are not cloud-washed, but are more purpose-built to understand dynamic, ephemeral IP addresses. So you also want tools that really understand AWS. What does that mean? They understand the context, right? I can take a logging tool and I can ship all of them support taking all your CloudTrail and pumping it into there. Now that's an awful idea, right? Because like I said, you're going to end up with 25 million described tables from DynamoDB and 3 messages that really mean anything important to you. So you really want to find tools that are smart enough to understand context, what they should be doing with things, how they should be, what they should be alerting on, how to filter out the noise, what does it mean when something happens. So context and actionable intelligence. So again, those generic tools are often not very effective. So CloudCheckr, come check out the booth. We're here. We have one of the booths in the trade center. We give you a lot of things around. We'll give you the ability to visualize inventory in your cloud, so what you have running there, even if it's dynamic auto-scaling, even if it's across hundreds of accounts. Ability to audit and understand your cost and your security, analyze your usage, knowing what you have there. Monitoring for changes, right? You want to know when people are changing configuration settings, whether there's security configuration settings or regular, network settings or what they are. Best practices. We have over 350 best practice checks around, am I using my RIs right? Are my security groups wide open? Is my CloudTrail enabled? So, and then just a historical record of everything you've done. So come check it out. It's a SaaS platform, so you can go give it a 2-week trial. Questions? In the back. Well, so the question is there any best practices around seeing if somebody spent a lot of money? Yeah, absolutely. So we do unified cost, security, and inventory platform. And really, this is a security talk, so I'll weave this in here. One of the things that we see people doing is setting budget alerts from a security perspective, because I've actually seen one of the biggest security problems I've seen is people taking their IAM access keys taking their IAM access keys and accidentally putting them in a script and publishing it to GitHub, right? I mean, and these are government organizations that are like the ones that are the most secure data. These are the ones that, I've seen it that happen to them. And now what happens is, a hacker will grab those keys and then go spin up 48 extra larges and start Bitcoin mining, right? So one of the interesting ways to monitor for security is to monitor your budget. And when you see your price jump by $2,000 an hour, you know somebody probably is Bitcoin mining you. So, it's kind of a funny way to tie cost and security together. Other questions? Yeah, absolutely. I mean, there's, we're in an interconnected world, so everybody's programs need to talk to each other, right? So how do we do this? As he might have kind of alluded to, the idea is we set up multiple VPCs and we start to use secure authentication between them. And that might be the API gateway. That might be, lots of different ways. Maybe you set up a VPC peering connection. But if you do that, then you have to set up the proper routing tables, the proper network access control lists. So every situation, there's not an easy answer to that, but absolutely, we have to get more comfortable with how do I set up, because everything's got to talk to each other these days. So now we have to not, I know in the keynote, one of the things they brought up was, why is MongoDB so successful? Because by default, they turn everything on, right? As a developer, it's very easy. My life's much simpler if everything's just turned on, right? That's the biggest reason why we have security problems, because my life is much easier if everything's turned on. But, that's also much easier for the hacker, right? It makes his life a lot easier too. So now we have to go turn everything off, and all of a sudden our apps stop working. So, yeah, it sucks, but that's life, and we got to figure out how to create secure connections that are properly limiting what you can access. Other questions? Yeah. So good question, and this is not a cloud question. This is a security question, because it applies just as much to everything else. So if you have dev and test accounts, how much do I care about the security of my dev and test accounts? Well, I'll tell you what. So how does this become a problem? You lock down your prod system. Your dev account you leave wide open. Some hacker breaks in there and gets control or installs some Trojan on there, and he ends up finding out, he steals some password hashes, hacks them, finds out your password, and figures out he can also use that in your production network. Or, he replaces some file you run with a file that installs a Trojan horse or a keylog stroker on the developer's desktop workstation. And then later on, the developer logs on the production system. So, the reality is we can't, it's just impossible to lock down your dev and test environment as well as your production system. But to say, well, those are dev and production and I don't care about the security, really is a problem. You have to at least consider that if somebody was to take over, what could they do in that environment to then, and then try to get into there. I mean, you still absolutely cannot afford to have hackers gain access to those test and dev environments, because they could do things. It's just too easy to Trojan something, put a backdoor in there, and then use that to kind of leverage their way in. So, so absolutely. I mean, we ride the Amazon, the AWS wave, and they put out CloudTrail, which made our service much more valuable, because now we have big data to consume. They added VPC flow logs, made our service much more valuable. So, the more Amazon can put out, the more complexity and the more data we get, the more you need tools to help actually see what's going on, keep track of it, and understand that. So, I mean, it's good overall for everybody. The problem is, if you turn CloudTrail on, what do you do with it, right? Without some kind of tool to monitor it, it's probably not particularly useful. It's still good to have it, but you're not going to have any idea what's going on. So, yeah, and the CloudWatch logs is the other thing that's really valuable. Those are the three core things that have just been super valuable to help provide security for AWS. So, right, so snapshot security. So particularly in the case of snapshot security, what I would refer to is the idea of kind of privileged user access. So, so that does not mean a hacker is going to easily get to it, because nobody can get to a snapshot without having at least IAM access. So if your IAM secured, then somebody's not going to get to a snapshot. But what you do have to worry about is insider threats. So if one of your QA guys has access to describe or whatever the right API call is to actually get your snapshots, he can basically take a copy of that snapshot, take it home, restore it to his SQL server or his MySQL at home, and then start brute forcing your production database passwords using some tool like Jack the Ripper, or I forgot what one of those password cracking tools, right? So that's really, it's not an external threat from that perspective. It's more of an internal threat. The external threat would be that some external hacker gets an account with limited, gets an account that's not a full admin. Maybe they get one that's just a QA user. Then that can be used to kind of escalate their privileges. So, questions?
Endpoint verification and maybe the use of jump boxes to access sensitive data?
So what do you mean by endpoint verification?
It's okay for you to connect to the server from work, but if you were from an IP address at home, hands off. Or I want to know where my endpoints are originating from.
Yeah, so kind of endpoint verification is an interesting one. I mean, I'm just thinking now through, does Amazon have a whole lot of those capabilities built in? I mean, the fact is, in today's world, everybody wants to be working from home and all that. So I generally push people away from trying to be so stringent to say you can only get to there from a specific IP address, and more focus on how do I secure that. So you require SSH keys or whatever. So you have the advantage of why we have networks, but you're still secure. But a lot of organizations still require, okay, if you want to get to the Amazon, to the AWS network, you still have to VPN into our network, go through all our IPS and IDS and all those filtering and through our firewall, and then from there you can RDP or SSH into a Bastion host there, and then you can go from there. So I mean, that's a very secure way to do it. It's just kind of a lot of work and all that. So I think the world is eventually going to push to the point where you're going to be able to connect from anywhere, but you have to make sure you have really strong SSH keys to do it, and you do have to all connect into a Bastion host. I mean, anytime you're connecting into Amazon or AWS, your VPC, I really think everybody ought to be using a Bastion host as a jump server, and you shouldn't connect to anything directly except for that Bastion host. That's really a very, I consider, low-hanging best practice, right? Like if you're doing anything other than that, you're probably wrong. So I hope that answered the question. Yeah. Questions? We still got 90 seconds left. So I'll be up here too as well. So if you guys want to come up and chat one-on-one, I'm here. Thanks a lot. And please go check out the booth and give the software a try. I'd appreciate it. Thank you.